What is up? Hope you're doing well. Welcome back to Nick Does Algos. In this lesson, we'll be covering the Hackerrank Easy Rated Algorithm ACM ICPC team. Great name for a question, right? Well, in this question, what do we have? Well, Hackerrank provides that there is some kind of competition, and at this competition, there are teams of 2 people. And we've got our teams of, well, our people. We'll call them students. Our topics array represents our students. Each item in our topics array represents a student. But what is it actually spelling out? Well, this student's topics are represented by this binary code here. If they know a topic, that means they'll have a 1 next to it. If they don't know the topic, they will have a 0 in that position. And in this question, you can see that there are 5 topics for each student. This student knows 3 of the topics. This student knows 4 of the topics. This student knows 1 of the topics. And what is this question actually looking for? Well, this question is saying if for our students in our topics array, if we arrange these students into teams of 2 in any combination possible, how many topics do they know? And not only how many topics do they know, what is the maximum number of topics that occurs, and how many teams know that number of topics? Kind of wordy. Might not make sense when you're listening to it, but read through the question a little bit, take a look at these examples, and I'm sure you will start to follow. So the answer for this first little example would be 5 and 1. And what does 5 and 1 mean? Well, the highest score, the most number of topics known by any possible team of 2 students is 5, and that occurs once. Only one team knows 5 topics. We'll scroll down to this next example just to work out a little bit more. On this example, we've got 4 students. Again, our topic number is 5. Each student is evaluated on 5 topics. And it seems that based on this sample output, there will be 2 teams that know the maximum topic number of 5. And these are actually the numbers that we'll be working with in our example, so we'll see those a little bit more in depth. So let's go ahead and jump over to Replit and start to get to work. Okay, so there are some quick variables that we'll need to establish because they don't come standard in Replit. If you were to go into Hackerrank and type print n and run the code, you will see that we are provided, well, there we go. You'll see that we are provided an n. Not quite in the case of Replit though, so we will go ahead and write out our n, which is actually the length of topic. N is the number of students. So each item here represents a student. That means you can just do length of topic to find the number of students. And then what is M? Well, M is the number of topics that the students are being evaluated on. So we can go ahead and take the length of any position in our topic array, and that will give us the number of topics that the students are being evaluated on. Okay, in this line of code, I'm not sure if we actually have to do. I did it because I was having a little bit of trouble with Replit. It's not necessary in Hackerrank, so we will edit it out later. But for now, we will write this little loop to turn each one of these strings into arrays. So very quickly, for I in range n, we will do topic I equals list topic I. And all that's doing is taking each topic string and turns it into an array of its own, a list of its own. Okay, so that should take care of all the prep we need to get this question set up. Let's start to think about what we actually need to do. Well, we need to build some teams. We need to build out all of our possible teams, and we need to evaluate if the team knows a topic or not. So we don't care if both students know a topic. We only care if one of them knows it. So here, both students have a 1. We would only keep track of one of those. In this second topic, student 2 knows it, student 1 does not know it. That would still count. We would increase a counter, some kind of stored value, by 1 for that position. Overall, between these first 2 students, looks like they will know 4 topics. They won't know topic number 4 right here, but they will know the other 4 topics. And we'll see more as we go through this question. But what do we need? Well, first we need to build out the teams before we can evaluate if they know a topic or not. So what would the teams be? Well, the first team would be, let's say team 1 and student 1 and student 2. Next team, let's say it's student 1 and student 3. Last team, let's say it's student 1 and student 4. Then we can move to student 2. Well, student 2 and student 1 are already a team. Student 2 and student 3 aren't, though, so we'll go ahead and put that there. Student 2 and student 4 aren't either. We'll go ahead and put that there. And then you may notice that there's only one team left, and that is student 3 and student 4. So we need to write some loops where we can create these teams and start evaluating their topic knowledge. And then, as I said, we will have a stored variable that will store the number of topics that they know. So to do that, we're going to have to write 2 loops, actually 3 loops. It's kind of a dense one, but let's get started with our outer loop. And what will our outer loop represent? Well, it will represent this, our first team column. So for I in range, what will the range be? Well, we know that we need 1, 2, and 3 in this range. Or actually, we'll need 0, 1, and 2 because student 1 will be index position 0 of topic. So we can go ahead and write this as n minus 1. Okay. Oh, we have a little syntax error for I in range n minus 1. And just, it might be a little confusing. We don't need to evaluate index position 3 in column 1. We need to evaluate index position 2 because that represents student 3. Hopefully that makes sense. What I could also do is I could delete the 1 and write 0. I could delete the 2 and write 1, and I could delete the 3 and write 2. And then if I got rid of that and I got rid of that, those are the first columns, 0, 1, and 2. And that's why we can do range of n minus 1. Because what's n? N is 4. If we did n was 4, if we left it as that, the range would be evaluated up to index position 3, but we don't want to evaluate index position 3. We want to evaluate index position 2. Okay, hope that makes sense. And hopefully whatever I just deleted won't ruin any explanations here. Actually, we'll just, we'll control Z. Okay, great, there we go, got it back. Okay, so we'll have to do another loop, and like I said, our other loop will satisfy our second student in the team column. So we'll write for j in range. And how would we write this one? Well, the lowest j, looks like I didn't edit something. Oh, I didn't. Sorry, let's fix that up. I apologize. Okay, I think we're done now. Let's go one more. Yeah, okay, perfect. All right, so for j in range, and what will this range be? Well, you can see that the lowest j is actually n plus 1, and the highest j is n itself. So we can go ahead and write that as, I think I just said n plus 1, I meant I plus 1, so that will be I, lowest number will be I plus 1. And why is that? Because I will be 1, or first I would be 0. That means our first j would be 1. And like I said, we're talking index positions, not student numbers themselves. And then what would that go up to? Well, that would go all the way up to n. we will evaluate the last student in our second team column, or second student column. Okay, great. So we've got our 2 major loops established. And like I've mentioned a couple times, we want to store a value and keep track of it for the number of topics that our 2 students know between the 2. So we'll go ahead and set it equal to 0, and then we'll write a loop. And as we're looping through, if student 1 or student 2 in our team, the first student or the second student in our team, has the topic covered, our counter will be increased. So we can write that as for num in range m, because what is m? M is our number of topics, and we'll want to evaluate all the topics to see what the students know. And we can then write a conditional statement that will determine whether our topic count is going to go up or not. And when would the topic count go up or not? Well, it would go up if topic I, right, because that's our first student. We'll look at our first student. We'll see if they know the first topic. And how would we do that? Well, we would take the first num of our loop here, our first iteration of our num loop. And if that equals 1, the counter would go up. Let's go ahead and put the colon, topic count. Of course, we know how to write topic count is going up. That would be topic count plus equals 1. But that's not the whole condition, right? It's if the first student or the second student, which would be topic J of num, equals 1. That would also increase our topic counter. Let me fix up that right there. Topic count. Okay. All right, and just to briefly run through that, make sure it's making sense to everybody. What is this first number evaluating? Well, what is topic of I? What is I? I is 0. The first iteration of our I loop is 0. And what is num? Num is 0. The first iteration of our num loop is 0. So it's topic 0, 0. Well, that's the first student in our topic array, and it's the first topic. Is that a 1? Yes, so our topic count will go up 1. In this instance, we don't even need to evaluate the second condition because it's an OR statement. Of course, this guy already satisfies our condition, so we don't need to even look at the second. But we'll do it anyway. So what is topic J of num? Well, we know that J is I plus 1. What was I? I was 0. So topic J is 1. That means we're taking a look at this student here. And what is num? Well, num is 0. We're going to evaluate the first topic in this student's topic range. And that will also equal 1. Okay, so I hope that's making sense. That's really the bulk of our loops. That's the meat of it. But there's one last thing we need to do. We need to keep track of it. So we'll create a scores array and make it empty. And then we'll go, I think it's to this loop here. A little hard just to eyeball. And we'll do scores dot append. Oh, sorry, let's do scores, not score. Scores dot append topic count. Because our topic count will reset after every team because of where we have topic count established in our loops. So we will see how many topic counts a specific team knows, pop that into our scores array, and then do the next loop for our next team. So let's go ahead and print this to see if we are storing all of the scores that we want to score. Let's run it, give it a run, and there we go. Team 1, which is represented by this team here, they will know 4 topics. Team 2, represented by this team here, they'll know 5 topics. And at a quick glance, you can see that the max score here is 5, and it occurs twice, which is exactly what needs to be outputted according to Hackerrank. Like I said, we're using this same example here. We'll need to output 5 and 2. And so now I'm sure you guys are aware that we could do another loop. We could loop through our scores loop and maybe make a counter, and each time we encounter the highest score, we'll increase that counter, and then we would go ahead and return the max score as well as that counter. But we can actually do it a little more simply. We'll put this in array just because that's the format that Hackerrank accepts here. And what will we put here? Well, the first number in our array needs to be the max of scores. Because we want it to be 5, right? We want to see how many times, we want to see the highest score that's achieved in our scores array. And the second number here, what will that be? That will be the number of occurrences. So what score are we looking for? Well, we're looking for the max score, of course. And we can actually do scores.count max score, and that will give us the occurrences of our max score in our scores array. Oh, let's go ahead and print this for proofs so y'all believe me before we transfer it over to Hackerrank. And there you go, our answer array. All right, so like I said, this area is all superfluous. We can go ahead and comment that out. We're actually just gonna go ahead and delete all this. And you know what? Formatting this is it's very annoying to keep things PG. So I'm just gonna go to my VS Code where I have this code stored and copy and paste it over to Hackerrank. And let's go ahead and run the code just as proofs that it's working. And there you go, passes both of our sample test cases. We will go ahead and run this code against all of our test cases. A little slow, and it makes sense. There's a lot of loops inside of loops here. Our big O time is quite slow. It's hard to get this one down because of all the loops that are necessary. But there you go. You can see that we passed all sample test cases, or all actual test cases, and we got this one right. So I hope that makes sense. I hope you guys are following. If not, please feel free to pop any questions down in the comments below. If you have a better way to do this, if you can get your big O time down, please share that as well. I couldn't really find any great answers on first Google of the Google. And that's it, guys. Thank you so much for watching. This is Nick Does Algos. We post these algorithms all the time. If you are currently covering algorithms, I highly recommend you hit subscribe, as we post these just about every day. Thanks for watching, and hope to see you in the next one.